In the past few videos, we've learned about rational functions. And so now what I want to do is I want to talk about this particular rational function and its graph. I just want to graph it. I want to do all the things that we've talked about in these videos. And so I want to talk about the vertical asymptotes, the horizontal asymptotes, and I'm sure this one has a horizontal asymptote because the degrees of the top and the bottom match. I want to talk about any holes. I don't have to worry about slant asymptotes because again we have a horizontal asymptote. I want to talk about x and y intercepts, if those are even things this function has. Those haven't showed up in a video yet, so we'll have to talk about them here. But the first thing I want to talk about is whether this is in lowest terms, because I know that to talk about the vertical asymptotes and the holes, I need to know whether this is in lowest terms. I'm going to need to factor the top and bottom to even know that. But that's okay, because eventually I might have to set the bottom equal to 0 to talk about any vertical asymptotes. I might have to set the top equal to 0 for a reason we'll talk about in a moment. So let's just go on and factor first. And that's a good rule of thumb. Well, looking at the bottom, it's a cubic polynomial with 4 terms, and I see some nice patterns here. I think I get to factor it by grouping. So on the bottom, I could factor out an x squared from the first two things, and I'm left over with an x minus 1. On the bottom, I could factor out a minus 4 and I'd be left with an x minus 1. So that's looking pretty good. So just on the bottom, factor out that common binomial, I have x minus 1 times x squared minus 4. And so let's see, that's x minus 1 times x minus 2 times x plus 2. Now let's see if we can factor the top. Well, from this first pair of things, again, I'm thinking factor by grouping. I see 4 terms. I see some nice kind of patterns going on. Let's factor out an x squared. I'd be left with a 2x minus 3. Well, here, I guess I'm just going to factor out a minus 1. And then I'm left with a 2x minus 3. I can factor the 2x minus 3 out front. And now I can factor this as the difference of 2 squares. And I find out this was not in lowest terms. I have x minus 1s that cancel out. And so right away, there's going to be a hole when x is equal to 1. So at x equals 1, I'm going to end up having to poke a hole in my graph. And this lets me go on and deduce that maybe everything else I deal with is easier if I have this equivalent expression. These are equal everywhere as long as x isn't 1, where we'll have that hole. All right. Well, unfortunately, I'm going to have to erase all of the work I just did to factor it, but I have the final factored form there. And I guess if you need to go back and check out what I did, you could pause the video here or just roll it back later. All right, let's talk about this pretty vertical asymptotes. They happen where the bottom's equal to 0 over here. Of the expression in its lowest term. So I have an x equals a minus 2 from this piece and an x equals 2. Two nice, happy vertical asymptotes. Horizontal asymptote, well, I already mentioned the degree of the top and the degree of the bottom are the same. It doesn't matter which one I look at because this is a degree 2 polynomial when I multiply things together. This is a degree 2 on top. So the horizontal asymptote is 2 over 1 or just 2 because that's the quotient of the leading coefficients. All right, I know where the hole is, I know where the vertical asymptotes are, I know where the horizontal asymptote is. Let's talk about x-intercepts. X-intercepts happen where the function is equal to 0. And because I've canceled out that x minus 1, I'm just going to use the simpler equation over here. Okay, well, for a fraction to be equal to 0, the top's equal to 0. So, to find the x-intercepts, we can just set the top equal to 0. We can find the zeros of the top. Make a note of that here. X-intercepts happen where the top, in lowest terms, is equal to 0. No, that makes me happy. Because now I know what the zeros of the top and what the zeros of the bottom do. The zeros at the bottom give me vertical asymptotes. The zeros at the top are going to give me x-intercepts. Zeros that were in both places, the x minus 1 that canceled out, that gives me a hole. So I kind of know what all the zeros of all the polynomials involved do. Ones that cancel out give me holes. Zeros of the top give me x-intercepts. Zeros of the bottom give me vertical asymptotes. All right, so where are those x-intercepts? Well, this piece would be equal to 0 at 3/2, right? Just add 3 to both sides, divide by 2. Set this piece equal to 0. Get an x-intercept at -1, 0. I have a hole, a vertical asymptote, a horizontal asymptote, and 2 x-intercepts, 2 vertical asymptotes as well. Let's find the y-intercept. All right, the y-intercept happens when you plug 0 in for x. Well, on top, if you plug 0 in for x, I just get out a 3. On the bottom, if you plug 0 in for x, you just get out a 4. You could do that over here. You'd have to multiply some things together. You'd still get 3/4. So go with the easiest expression when you're doing any of these calculations. All right, well, let's start to graph our rational function. All right, I have x-intercepts at 1.5 and -1. I have a y-intercept at 3/4. I have a vertical asymptote at -2. Another vertical asymptote at +2. And I have a horizontal asymptote at 2. Well, I think I might need to plot some more points to figure out what's going on. Because there are going to be 3 pieces to this graph. And I know that because there's a left and a right to this asymptote, and there's a left and a right to that asymptote. There's 1, 2, 3 things. Well, if I think about my vertical asymptotes, x equals -2 and x equals 2, that's chopping the x-axis up into 2 spots. So I have a left, a middle, and a right. If I had 3 vertical asymptotes, I'd have 4 spots to have to worry about, always 1 more. All right, well, I need a table of values to help me out. In the middle here, though I'm pretty sure my graph's going to have to go down towards its vertical asymptotes. All right, but let's pick some x's and find some y's to help us out here and out here. So I'm going to use my handy-dandy TI-83 here. And I can't believe I'm going to put a video on the internet with me saying handy-dandy, but oh well, that ship has sailed. So I have my top in parentheses divided by the bottom. And I could type in either one. I'm going to type in the one that I think is easier. It does make me use a few extra parentheses. All right, so there is my function typed into my TI-83. I want to come back into the table. And let's see, over here, 1, 2, let's put in -4 and -3. And let's plot some points. All right, so 1, 2, 3, 4, 5. All right, so at -4, the y value I get out is 2.75. So come over here and 2.75, something like there. And then at -3, I get 3.6, so quite a bit. So 1, 2, 3.6, quite a bit higher. Well, my graph's going to have to get closer to its horizontal asymptote and closer to its vertical asymptote. All right, well, I think I know what's going to happen on this other side now, just having looked at this. But let's not take anything for granted, and let's plug in x values at 3 and 4. All right, at 3, I need to go up to 2.4. So something about right there. At 4, just barely above 2 at all. And so, yeah, go closer to my asymptotes, and there's my nice happy graph. And if I wanted to take a peek at my graphing calculator just to see how I did, I'm feeling pretty good about this. I never trust just the graphing calculator, but I don't mind using it to confirm what I did by hand. We could even now graph in y equals 2, the horizontal asymptote. That makes me feel really good about what we're seeing here. All right, We will do more examples of rational functions in class. I hope that this sequence of videos is helpful.